I am Sudalekanna, Assistant Professor, Department of Mathematics from St. Mother Teresa Engineering College. On behalf of management and principal of St. Mother Teresa Engineering College, it's my great pleasure to welcome you all 3-day national level faculty development program on fuzzy history and its application. I would like to extend warm welcome to our respected resource person, Dr. Kameshwari, Associate Professor, Department of Mathematics, Tyagarajar College of Engineering, Madurai. She is having 21 years experience in teaching field. She has published 20 papers in international journals. She has presented 32 papers in national and international conference. So she is doing lots of project work in various places. She got many awards and recognized by various associations. So I am very happy, honored to welcome our respected resource person, Dr. Kameshwari ma'am. Once again, I welcome all the participants and our coordinator, Dr. Victor Emmanuel sir, and Shyam madam, and Dr. Kodimandri and Mr. Sundar Singh sir, and to the faculty and all the participants. So welcome you all. I hope it will be very good and grateful on the events. Thank you very much.
Shall I start, Victor?
Yes, ma'am.
Okay, can you see the screen? Is the screen visible? Is the screen visible? Necessary hard work will not be answered sometimes. Now let us get into fuzzy. What actually a fuzzy is? The approach of fuzzy logic imitates the way of decision making in human that involves our intermediate possibilities between digital values yes or no. It works on the level of possibilities of input to achieve the definite output. We are going to see it elaborately in future. How fuzzy arises? The question arises in this situation that is there any possibility to assign a truth value or a membership value between 0 to 1? Yes. There is a possibility to assign membership value between 0 to 1 that arises fuzzy. When fuzzy occurs, now we are going to integrate continuously in order to get into the answer for the reason for the evolution of fuzzy logic or fuzzy set. When the available information is found to be incomplete, imprecise, inconsistent, uncertain, vagueness, fuzzy occurs. See the situation. These are all situations in which fuzzy occurs. We don't know clearly the difference between incomplete, imprecise, inconsistent, uncertain, and vagueness. We are going to see it in detail one by one. Precise reasoning. Computer manipulates precise facts only. It will not manipulate imprecise reasoning. But we are now working in the part of intelligent systems where it need to work with imprecise reasoning. Let us see it in detail later. Examples of from precise facts are the air temperature is 80 degrees Celsius. This is precise. This is concrete. Concrete information provided here is precise. The speed is 100 km per hour. She is 15 years old. Here all the informations are concrete and precise. If the temperature is 280 degree and the speed is less than 45 degree, then the pressure is 180 degree. The concept of if then involves fuzzy logic. This involves fuzzy sets. These are related to precise reasoning. What are then imprecise reasoning? Imprecise reasoning can be worked by human brain. That is, they are going to give judgments for vague values because it requires human intervention. This computer system cannot do this imprecise reasoning, but we are now trying to imitate human brain through artificial intelligence, through data analytics and machine learning. Examples of some imprecise facts are the air temperature is cool. Look here, the value given is 18 degree. Instead of saying by concrete information, we are just giving it by means of Imprecise reasoning. This is cool. Coolness depends on person to person. What degree I can apply to this coolness, whether it may be 18 degree or it may be 20 degree. The speed is fast. Fast also depends on the person. Here it is given as 100 kilometer. To myself, 40 kilometer speed itself is a fast one. So it also varies. Okay. She's young. Young also varies from person to person. Every 40 or 45 years old lady will be thinking that they are too young. But as far as a 20-year boy is concerned, he may be treating them as an old. So these are having imprecise information, that is not concrete informations. How are we going to deal with informations? Why should we deal with these informations? Because we need to address these information into a mathematical value. Is there any mathematics available to provide numeric value to these imprecise words, that is cool, fast, young and all? I don't know still now. Let us see, is there any mathematics available? Already I told you that there are some background in which fuzzy occurs: incomplete, imprecise, inconsistent, uncertain, and vagueness. Now we have seen what is imprecise. Now we are going to see uncertain. Other things, if you are interested, you can go and take. Here today I am going to address precise, imprecise, and uncertainty. Fuzzy in uncertainty. This uncertainty can be dealt in two ways. One by means of fuzziness, another by means of randomness. Fuzziness deals with membership value of an element. Randomness deals with chance of an event. So here comes the study of possibility theory. Here comes the study of probability theory. So probability theory and possibility theory both are going to give the valency between 0 and 1. So here confusion starts. This is also going to address the valency between 0 to 1, but at what situation? This is also going to address the valency between 0 to 1 at what situation? Can they address the same situation? The context in which probability theory can be dealt, can we deal with the same possibility theory also there? There are so many questions that arise continuously. Yes, let us see uncertainty still more. Uncertainty can be divided into statistical part and non-statistical part. Ours is a non-statistical part. Here we arrive at vagueness, ambiguity, discord, and non-specificity, and so on. Still, we are going to see some background we are required before getting into fuzzy sets deeply, because the word fuzzy itself may be confusing to everyone. In order to get clear picture on this fuzzy, we need to address with some of the backgrounds to which we can address fuzzy, we cannot address fuzzy. Other type of uncertainties are stochastic uncertainty, linguistic uncertainty. We are going to mainly address with this linguistic uncertainty. This is the reason why fuzzy has evolved. This is a very interesting uncertainty that we are going to see now. What you can see here, you can see here a picture that contains green apple. Here it contains a red or rose apple. Suppose you are asking your son to buy a green apple. There is an uncertainty regarding the availability of the green apple. What are the situations that arise this uncertainty? Two situations arise. One is chance of getting apple. Another one is guarantee that the apple is green. What mathematics can address this chance and what mathematics can address this guarantee? The mathematics that address this chance is nothing but by principle of probability. This I don't know. Let us see. Is there any answer for addressing this guarantee in our mathematical background? Can same mathematics address this situation? Can this uncertainty guarantee be addressed by the principle of probability? How one can define the color green? The definition of this particular green will vary from person to person. Here uncertainty occurs in the color of the green, not in the availability of the apple. This uncertainty cannot be answered using probability theory. Can this uncertainty be addressed by crisp set theory? All these questions, I don't know the answer. Yes. Hello?
PPT is not visible, ma'am.
PPT is not visible.
The PPT visible only, sir. There is two Kamachi model is there. One is upper, another is down. You go down, that Kamachi model you can print, sir, it is visible. So we are
You go
seeing
to
only
you go to my name and ping there. Then you will be getting the
two
screen
common
of myself.
is there. Only second one. Only second one. Another one is down, sir. The down you can pin, not second one.
Yes,
Continue, ma'am.
yes. Yes. Thank you so much.
Yes.
We
Okay.
are going to bombard with many interrogations. Through that only we are going to come to a clear picture why we need fuzzy. Look at these questions. When corona be eliminated? When corona be partially or totally eliminated? What is the chance of eliminating corona? Which of the above sentence contains uncertainty? 1 or 2 or 3? Which question is meaningfully asked? Is the question possess meaningful uncertainty? Even though uncertainty should be a meaningful situation. Uncertainty should be meaningfully raised. Otherwise, it is not eligible to address through fuzzy set theory. How can we address this uncertainty mathematically? How can we address the chance mathematically? Still far, we are just interrogating questions by raising some situations. Can probability theory address the situation, or crisp theory address the situation, or fuzzy set theory address the situation? Since fuzzy set theory deals with the assignment of valency between 0 and 1, there is another subject, that is probability theory, that also deals with the assignment of valency between 0 and 1. Are they going to address the same context of study? To the context where fuzzy does more efficiently and probability do the same, or they have the same principle of working if the assignment of valency between 0 and 1. Now I am giving the word balancing means values between 0 and 1. I'm going to change this word valency or value in future by some other word that is very important to our context of study. Why the word set is annexed? Why the word set is annexed with the word fuzzy? It means fuzzy has any connectivity with the usual crisp theory. What is the valency of the usual crisp theory? How can we transit ourselves from the usual crisp theory to fuzzy set theory? We are going to integrate, bombard with the integrations to get the answer for the need of the study of fuzzy mathematics. Now I end up with the statement that how can we address the chance mathematically? Here there is an answer. Probability deals with the chance of occurrence of an event that is futuristic. Probability is going to deal with the chance of occurrence of an event, whether the event can happen or not. It depends on futuristic. And probability or statistics are coming one after the other. It deals with certain data of an occurred event. The event has already occurred and we are going to deal some statistical analysis in it. What about this fuzziness? It is going to deal with the uncertain data of an occurred event. Statistics is going to deal with the certain data, and fuzziness is going to deal with the uncertain data. Some of the words that can be addressed through the principle of probability are, since we are teacher, we could have handled the probability theory at least, at most, exactly, probably once. Can all these words be addressed by fuzzy? That is one of the another question. I already told you we are going to bombard with these situations and interrogations before getting deeply into fuzzy set theory. And another type of uncertainty we are going to understand here. What about these roses? This rose is red. If I am asking whether this rose is red or not, you will be immediately saying no. With respect to the rose color rose, I am going to deal with the answers for these two roses. With respect to the membership value of rose color rose, we are going to assign the value here as 1, here as 0, and here as 0. What about this? What about this rose? What value can I assign with respect to the rose color? Before knowing fuzzy set theory, is there any possibility to assign a value? Yes, I know the other subjects, probability theory is also allowing me to produce the valency between 0 and 1. Can I apply probability theory in this context? I don't know. Let's see the answer later. And what color is the leopard is? And can you give me an exact color representing by this picture? And also geometric uncertainty. Is it a circle? Is it probably a circle? Is it almost a circle? To these questions, what type of answer, from which subject I can give answer to this? Can probability alone we address this situation? or Fuzzy can answer to this situation? I don't know. Let us see. I already told you we should bombard with the questions, and also we have to understand historical background of the evolution of fuzzy set theory. As far as fuzzy mathematics is concerned, it is essential to know about the historical background, how fuzzy theory is evolved. Does it possess any interlinks with the other subjects? Since the performance of the fuzzy set depends on the context of study or problem background, to some problems, it exhibits excellent efficiency. To some other types of problem, it gives moderate efficiency. To some context of study, it cannot be applied at all. For these reasons, it is necessary to know essential historical background on the evolution of fuzzy set theory. Now we are going to learn some historical background of fuzzy set theory. As far as mathematics is concerned, the information evolved from mathematics is based on two things to my knowledge. One is for essential, another is for intuitive. Look to these essential scientists who contributed here, philosophers. Essential based mathematics can be given by non-mathematicians also. Philosophers such as Plato, Socrates, Aristotle, and physicians Newton, Einstein. Einstein is given a very important equation, that is E is equal to mc squared, relativity theory, which has got Nobel Prize, and Newton gravitational force. Engineers, we are teaching engineering. We know Fourier, that is developed through conduction of heat, and Zade, he is an electrical engineer. Let us now know his name alone, and what he contributed will be knowing very soon. Statisticians and many others. Intuitive maths, we all know that the great mathematician Ramanujan has bombarded with enormous inventions through his intuitive capability, and many others also. So far, we have seen some situations which involve imprecision and uncertainties. Real world problems are very complex, very difficult. They are associated with some sort of imprecisions and uncertainties. How can we address this? Who invented the mathematics which address the uncertainty, which cannot be dealt by the principles of probability? This is very much important. The area to which principles of probability cannot be addressed by fuzzy mathematics. That this only we are going to conclude very shortly. Look here, still more history. Already I told you it is necessary for us to dig to some depth about the evolution of fuzzy set theory. Pythagoras told that mathematics were essential in understanding this world. Any inventions by the physicists or engineers or any social background economists, they need to prove their invention only through mathematics. Then only it can be validated, it can be concreted, then only it can be accepted as universal truth. So mathematics is like a slogan, it's like a god. It has to be felt by oneself. So mathematics, they are essential in understanding this world. Like we require sloga to understand God. Look to these persons. Who are they? I hope we can understand these persons. They are nothing but they have contributed much more to the logic theory. Logic is also a main part of mathematics. Because of logic, concrete mathematics such as topology, complex analysis, metric space, measure theory have evolved a lot. From the measure theory, we have derived another subject, that is probability theory. These persons have contributed much to the logical world, and Socrates is the senior most man, and his disciple is Plato, and his disciple is Aristotle. What they have contributed, we are going to see it now. They have contributed law of excluded middle and law of contradiction, what we have studied in set theoretical background and logical theory background. Law of excluded middle law is contributed by Plato. He said that A union A bar is equal to universal, even though it seems to be very simple in today's context, but it takes very concrete information, the duration where Plato and Aristotle lived. Contradiction is contributed by Aristotle. What he he has contributed A intersection A bar is equal to empty. This is also a very simple equation in this today's scenario, but it seems to be a very important equation in the duration where these people live. Plato said that there is a world beyond zero and between zero and one. Here's some confusion that there is a world zero and there's another world one, but there is a world beyond zero and one. He don't know how to say between. He might have forgot to substitute the word beyond by between. Look to this bottle. How will you address this bottle? Is this glass full or empty? How can I address this full or empty through logics? I need one more logical theory, that is trivalent logic. Trivalent logic that is given by Jan Lucas. What he told, between true and false, there is one more thing that is possible. Therefore, here it is said that truth value of filling of water in this tumbler is half. Still, we are just getting into the necessary history. Look at this man. The name of this man is the Lafayette, who is otherwise called as father of fuzzy mathematics. What he has contributed, he has extended the work of possibility theory into a formal system of mathematical logic. That is, he has extended possible theory into a formal system of mathematical logic. Even though he is an engineer, he has contributed into the mathematical logic and introduced a new concept for applying natural language terms. This is very much important. In future, we are going to deal with this natural language term. He has extended the possibility theory and contributed mathematics for applying natural language term. He has published his work in the paper, in the journal Information and Control, in the year 1965. What he said, he is the man who found the world between 0 and 1, which deals with fuzzy mathematics. Plato said that there is a world beyond 0 and 1. This uncertainty is eliminated by father of fuzzy maths, Lafayette, and he said that there is a world between 0 and 1. Prior to 1965, people used to believe that it is a probability theory which can tackle the different types of uncertainties in this world. But in the year 1965, L.S. professor, University of California, told that there are many uncertainties in this world and principles of probability theory can handle only chances out of different uncertainties. There are few uncertainties which cannot be tackled by probability. He is the man who evolved with such a beautiful and interesting and very much informations. He argued that we need something which is at a higher level compared to the classical set if we want to address different types of uncertainties or the imprecision which we face in this real world. By that way, fuzzy set theory has come into the picture and it deals with possibility theory. And Zara is the pioneer of possibility theory and he's contributing this invention to the natural language statements. We are going to deal with the natural language statements in a very effective way. Developed by Lafayette, he is an Iranian American. He builds upon his theory of fuzzy sets. Look to this possibility distribution. A suspect is a male between 20 and 30 years old. This is the information. A suspect is a male between 20 and 30 years old. A crisp set defines the age of this suspect as between in the interval 20 to 30. What about the 19 years old? A 19-year-old male would not be a suspect in this case with respect to the crisp theoretical background. And it is an impossible value to get into this 20 to 30. Now this age can be granulated into two different ways. One by means of crisp granulation, other by means of fuzzy granulation. With respect to fuzzy, we need some natural language where they are young, middle, old. Here we do not require it. Suppose a male between 0 and 20 and 30 is suspected. Here it is given as a suspect. Why it cannot be a 19-year-old? This granulation is not allowing here. In this fuzzy, we are allowing 30 years old man also as an being an young with some valency of 0.8, and also 50 years man can be given with 0.2 degree of membership with respect to old. We are allowing some intermediate, we are allowing some intersections of these words. We will be seeing, we are going to see this in detail. Possibility theory handles vagueness in the use of the language. What are the vagueness? Here the vagueness are present in these words: young, middle, and old. How to deal with? Why it is called as an vague? It is not concrete. It is not universally described by. It is not universally described, because when and once it is universally described, you and me are going to accept the same value. Your perception may be different with respect to young, and my perception may be different with respect to young. Because of that vagueness creates. Possibility theory handles this vagueness in a very effective way. Let us see it. Now we are in the transition of crisp set to fuzzy set. Where that transition has taken place? It has taken place in membership value. What do you mean by the membership value? Earlier I used the word valency. Now I am going to convert the word valency into a membership value. Valency is the word which is used by the chemist for giving value to a particular magnesium, like that, to particular chemical components. I'm going to convert the word valency into membership value, which is nothing but degree of belongingness. Already this degree of belongingness is dealt in the crisp background through characteristic function. In the crisp background, we are going to deal this membership value in the collection 0,1, that is bivalent. With respect to the fuzzy set, this belongingness is going to dealt between 0 to 1, which is contributed by Zadel. Membership function here, we are going to take as characteristic function as the membership function. Here, fuzzy function as the membership function. We know what a characteristic function is. That means for belongingness, it is going to give the value as 1. It is strongly printed. And for non-belongingness, it is going to give the value as 0. Sometimes we may honest at this, we can give as a value as 1. And with respect to the fuzzy function, if we are going to exhibit the difference in the notation also, here we are going to use the notation chi. Here we are going to use the notation mu. What does this a in the suffix represent? That's very, very, very important. We are going to see it in detail. It is having a special meaning to denote a here. Every representation is a special way of understanding. As far as mathematics is concerned, notation is very much important. We cannot take all the verbal nature everywhere. In order to convert a very big verbal statement, such as complex or compound statement, into a simpler form, we require mathematics. For example, relativity is equal to mc squared. That's all. E is equal to mc squared means it represents relativity, the gravitational force. So this A is possessing a specific meaning. Without this A, there is no characteristic function, there is no membership function. How this A is going to contribute it in detail later. This is a non-fuzzy environment. Why this is a non-fuzzy environment? Since it is allowing either the membership value as 0 with respect to height, or the membership value as 1 with respect to height. With respect to height, what will be the vague word? We can have tallness. With respect to the tallness, this man is going to possess the membership value as 0, even though he is 4 feet height. But what our fuzzy set theory is doing is going to give a wonderful membership value. He may possess 0.4 or 0.3 for being tallness of 4 feet height. But it abruptly neglects this person, so it is giving value as 0. Those who are above 5 feet only are going to have or degree 1. A man with 5 feet is also going to have the degree 1, and man with 6 feet tall is also going to have the degree as 1 in this context. So it is abruptly a meaningless situation to give the membership value 0 to 4 feet height man and also 1 to 5 feet height man. But our fuzzy is gradually giving values depends on the tallness. Now we are going to understand crisp and fuzzy by means of this. Here, if the gray value is 0, that is, if the gray scale is black, we are going to assign the value as 0. If it is white, we are going to assign the value as 1. Black and white, 1 or 0, on and off, true or false are all going to represent fuzzy, crisp set or crisp logic. Here, grayscale varies. That is fuzzy logic. Come to this situation, we are having two tumbler. One tumbler contains hot water and another tumbler contains cold water. Intuitively, we can understand hot means it is extreme heat, with extreme heat. Cold means with extreme coolness. Okay. Now we are going to assign 1 to the hot water and we are going to assign 0 to the cold water means what value we can assign to the warm water. Can I give any value in the crisp domain to this warm water glass? It is meaningless after assigning 1 to cold water and after assigning 1 to hot water and assigning 0 to cold water. It is meaningless to assign either of the value 1 or 0 to this warm water. So I may be struggling to assign the membership value in this context. I may be in seek of the some other subject apart from crisp set theory to assign membership value. This crisp set theory is developed logically by Boolean, and to assign membership value like warm water of a glass, subject fuzzy set theory supports a lot. Let us see it later. Just a minute. You are going to answer to this question. Identify the picture for crisp membership of fuzzy membership. Is the membership of tallness defined by crisp membership meaningful? Already I answered in this context that it is not a meaningful assignment of crisp membership for tallness with respect to height. Imprecision and uncertainty theory and fuzzy set theory. Now, in order to get deeply into fuzzy set theory, we should possess some foundation crisp set theory. As far as crisp set theory is concerned, we all know about the definition of crisp set. That is a collection of well-defined object. You look upon the word well-defined. If a collection of not well of this representation is to keep all these members from the universal collection in the denominator and this corresponding membership value in the numerator that we have seen already. This is the diagrammatic representation. It will result in this way. Since our universe is discrete, while representing diagrammatically, you take the members in the universe in the x-axis and 0 to 1 value in the y-axis. That means we are going to assign the membership value against each member in the universe. Against the word against will be represented in the y-axis. For 2, we have assigned the membership value as 0.3. Similarly, for 4, we have assigned the membership value as 1. By this way, we can denote geometrically. This geometrical representation plays an important role while handling applications. I will tell you later. This is the continuous inverse representation. Then characteristic function, membership function. We are going to understand the difference between characteristic function and membership function. Look to this table. This table represents name, height as the title, and degree of membership with respect to this and with respect to the fuzzy. It is given by their expertise. Already I told you, assigning this membership value in the fuzzy context requires high skill and expertise. By practice, you can get it. For this Christ, with the height 208, they have assigned the value 1 in the crisp context and the same value in the fuzzy context. But to the Bob, with the height value 167 centimeter, in the crisp context it is 0, but in the fuzzy context it is 0.15. 0 means it is not meaningful to assign the value 0 as a membership value to the height 167 with respect to the linguistic variable height. Is meaningless to assign value 0. So we are in need of fuzzy set theory for the meaningful assignment of tallness with respect to the height 167 centimeter attained by Bob. This is the diagrammatic representation for this background, and this is the diagrammatic representation for fuzzy background. This gives some smoothness in the curve structure. This is abruptly representing 0 and 1. No membership is allowed in between, either 0 or 1. This is a diagrammatic representation for another context: short, average, tall. This is the crisp context. This fully for 0, this fully for 1. Sorry, this fully for 1 and this fully for 0. This grayscale is allowing average also, but in the crisp context, this average person is not taking any value at all. That is the bad thing we need to understand through the assignment of membership value via characteristic function in the crisp background. Average persons will totally be neglected in this context, but average person also comes into the picture in the context of fuzzy sets. Now, fuzzy set operations. Already we have seen the basic operations such as union, intersection, and complement in the crisp background. Now we are going to see it in the fuzzy background. Let us start with equality. This is the crisp set, mu A is equal to mu B. Crisp set means property set. This is our universal set. X is our universal set. This is the property set. When two property set are equal means, then the membership collection will also be equal. With respect to the complement, this is a property A. Beauty means its complement may be ugly collection. Mu A dash of X is equal to 1 minus mu A. With respect to the containment, if the property A is contained in the property B means their corresponding membership value. That means we should not talk by means of the subset respect to the operations less than, greater than, and equal to. Mu A of X value is less than mu B of X. Union, already I have told you to look upon the word R. R means when imposing the condition R, your set will be enlarging. Enlarging means your collection will be maximizing. So now we are going to collect the maximum property value. A is one property and B is another property. We are going to make union of these two property. Can the property abruptly be make union? No, we are representing the property by means of the collection. So since the property is represented by means of the collection, it is a meaningful to connect it by the operator union. With respect to the membership, you should collect maximum value and the same element has to be considered. Look here, same element has to be considered in both the property background. Take the element X and look to this property and get its membership value. Take the same element X, look to the property B and collect its membership value. Now we have arrived at the membership value, that is a numeric value. Between these two numeric value, you take the maximum one, that will be the value for membership value of the union of these two properties with respect to the element X. Now you change another element and replace the element by Y. Now with respect to the element Y, look to this property A and get its corresponding membership value. Similarly, to the element Y, look to the property B and get its corresponding membership value. Now we will be arriving at the numeric value. Between these two numeric value, we know how to take the maximum value. That will be the value to the element Y in the universal set with respect to the union of the two properties in the fuzzy background. Same way for intersection, we need to collect the minimum value. We are going to see it through an examples now. Already we know these notations. What is this notation? This A represents some property. We know property is not explicitly given in this context. Similarly, the property B is not explicitly given in this context. The member X, X1, X2, X3 are the members. Similarly, X1, X2, X3 are the members in the universal collection. These members should be same. Yes, same. With respect to the property A, this member X1 is taking value 0.5. Similarly, with respect to the property A, the element X2 is taking the value 0.2. With respect to the property A, the element X3 is taking the value as 0. The same element is taking different value because the property is different. Now we are in the zone of two different property with their membership value. Now we are going to get its union value. Since the property is represented by means of the set, their union is possible. We have to check whether making union is possible. Yes, possible. It is meaningful also because A is represented in terms of collection. B is also represented in terms of collection. Because of this collection nature, union is possible and meaningful, and we are going to do A union B. How can I do A union B? That is said here as look upon the membership value of the same element in two different properties, same element in two different properties, and take its maximum value. Now take the element x1. Its value is 0.5 and its value is 0.8. Then what will be the maximum value? Maximum value is 0.8. Similarly, you can go for working to intersection and also complement. Intersection means to the same element with the different properties. You have to collect its membership value and look for the minimum one and take that value as the assignment of membership value to the intersection property. Assignment of membership value to the intersection property. Similarly, for complement, you have to subtract it from the universal collection value of the universal collection, that is 1. Subtracted from 1, you will be getting the complement value. Convexity. Why we require convexity here? Our title is Fuzzy Clustering Techniques and its Applications. In order to ensure about the collected clustering, we have to ensure about the property of being convex. So the convexity property is discussed in this area, and the convexity property is given by mu A is equal to lambda x1 plus 1 minus lambda into x2 is greater than or equal to minimum. This is the mathematical representation of a fuzzy set A for satisfying the property convex. A is the property defined on capital X. Fuzzy set A is defined on the A is a property defined on capital X, and the condition for satisfying convexity is given by this way. Convexity means when I take two elements with respect to the property, those two elements should lie under the area. So that is the condition verified through this inequality. So this is the convex fuzzy set. This is the non-convex fuzzy set. These are another example of two convex fuzzy set. This is the non-convex fuzzy set because when you take an element here and try to join those two elements. One element is outside and one other element is inside. The complete line segment cannot lie inside this region. Therefore, convexity fails. And relation of fuzzy sets, already we have seen equivalent, subset and proper set. Improper set means here you will be getting equality also, properties. Still with respect to the crisp set, we are concerning about its definition, representation of the sets, operations on sets, properties of sets. We have traveled representation of sets and operations on sets. Now our job is to verify the properties in the crisp collection is satisfied in the fuzzy background also. The properties which are in the usual crisp theory, how it is satisfied in the fuzzy theory also. Let us now understand what are the properties that exist in the crisp collection. Involution, commutativity, associativity, distributivity, idempotence, absorption, and De Morgan's law. These are some of the important properties. It gradually generalizes to the fuzzy collection also. From the crisp collection, all these properties generalizes gradually in the crisp collection also. But look to these two properties. These are the two properties that we have seen earlier through Aristotle and Plato. Plato and Aristotle provided law of contradiction and law of excluded middle. What is that? A intersection A bar is equal to empty, which is not satisfied in the background of fuzzy. And also A union A bar is equal to capital X, which is not satisfied in the background of fuzzy. Why? We are asked to take the minimum value with respect to this. If it is a property A, means it is the negation of that property. If a member X is taking the value with respect to this property as 0.3, say, what can be its value in A bar? 0.7. When taking minimum between 0.3 and 0.7, it will result in 0.3, not as 0. It will result in 0.3, not as 0, unless otherwise one of the value is 0. Unless otherwise one of the value is 0, it will never take the value 0 in this place. Because of that, this law fails here. How law of excluded middle fail here? The same example you take. Suppose a member X in the universal collection is taking the value 0.3 with respect to the property A, then its value will be 0.7 with respect to the property A bar. When making union, you must take the maximum value. That maximum value will here result in 0.7, not 1. Unless otherwise, one of the property set should take the maximum value as 1. In all the other cases, it will not take the value 1 because of the law of contradiction and law of excluded middle fails in fuzzy set theory. It should not gradually generalizes. When a new definition gradually generalizes a previous definition means it is no way useful for giving it to this world. So law of contradiction and law of excluded middle fails in fuzzy background. And there are some other extension of definition with respect to union and intersection. Mu A union B is equal to, we have seen as maximum of mu A of x comma mu B of x. This is another definition given by some researchers. Similarly for intersection also. Now we are going to expand the concepts of fuzzy sets. The operations what we have seen still for are the operations that are available in the crisp set theory, how it generalizes, and what are the properties that fail in the crisp background, which is exactly true in the, which failed in the fuzzy background, which exactly true in the crisp background. These are the things we have seen still for. Now we are going to see some of the expanding concepts of fuzzy set theory. That means fuzzy set theory will be having some speciality apart from the operations that are existing in crisp background. They are support, normalized fuzzy set, alpha cut, level set, convex fuzzy set, fuzzy number, magnitude of fuzzy set, subset of fuzzy set, and so on. We are going to understand all these through this example. Let X contains the elements 5, 15, 25 up to 85. That is the age. And we are going to, this age is linguistic variable. To this linguistic variable, I am going to assign this as the linguistic value. To this linguistic value, I am going to assign this as the numeric value. Linguistic variable, linguistic values, and the numeric values. You can ask me in this context that how these linguistic values are assigned. That depends on person to person and it requires expertise and skill. Okay, let us not go to that part now. Crossover points means mu A of x should attain with the value as 0.5. Since our assignment membership value is ranging from 0 to 1 and the middle value is taken as the crossover point. Are the fuzzy sets infant, young, adult, senior process crossover point? No, there is no 0.5 value here, so they are not containing any crossover point. Come to support. Support means collection of all x whose membership value is greater than 0. Collection of all x whose membership value is greater than 0. Look here, you are not collecting the fuzzy value, you are collecting the members from the universal collection. Verifying the condition that which members are having the value greater than 0, you collect that members. That will be giving the definition of support of A. With respect to the support of the fuzzy set young, this young is the fuzzy set. Young, adult, infant will be called as a fuzzy variable since it is a fuzzy set. Support of young, let us go to young here. This is young. Look for the value which are greater than 0, 0.2, 1, 0.8, 0.4 and 1. These are the values greater than 0. You should not collect these values. Go to its corresponding members. 0.2 is 15, 1 is 25, 0.8 is 35, 0.4 is 45 and 0.1 is 55. You are asked to collect these members only. You are asked to collect the members from the universal collection by verifying the condition whose values are greater than 0. So with respect to the fuzzy set young, the support of young are 15, 25, 35, 45 and 55. We can see this here. Yes. Maximum value membership is called as the height. Maximum value in the membership degree is called as the height. With respect to the infant, all the values are stable. Therefore, height of infant is 0. With respect to height, what is the maximum value membership value? 1. So therefore, height of young is 1. Similarly, you can go for the definition of normal. Normal means your height of that fuzzy set should be equal to 1. Subnormal means less than 1. Through this collection, we are going to see, is the fuzzy set infant normal? No, because no value is 1. No value of infant is 1, so it is not normal. Similarly, you can verify for young, adult and senior, it possesses the value. Since even one value is here, we can call this as a normal set. Here so many values are 1, here 2 values are 1. So fuzzy set young, adult and senior are normal. Similarly, what is the height? Height is the maximum membership. If it is a continuous universe means we are going to substitute maximum by supremum. So maximum membership collection. Similarly, alpha cut. Alpha cut is very much essential because fuzzy membership is a transition from the crisp domain to the 0-1 codomain. Fuzzy membership function is transition from crisp collection to 0-1 codomain. Anyway, it is a type of transformation. Once and when we transformed ourselves to some other places, we cannot stay back there for a very long time for further investigation. After doing some work in that transformed place, it is essential for us to come back to our original place. Reversing to our original place in transformation theory is called as an inverse transformation. Here also it is called as an inverse. It is not called as an inverse transformation. Instead, it is given as the word alpha cut. That means you must not collect the membership value. Instead, you must collect the members of the universal set by verifying some condition in the 0,1 codomain. That is, we are going to declare this alpha. This alpha is called as a threshold value in the application background. We are going to call this alpha value as the threshold value in the application background. Suppose we may be asking students, we may be asked to collect the student list who got greater than 80%. That means threshold value is 80%. We are not collecting the values above 80%. Instead, we are verifying the percentage marks. With respect to the marks, we are going to name of student. Likewise, collect the members in the universal collection by verifying this condition. Alpha is fixed, depends on the application. Alpha is fixed by the experts, depends on the application, and it can be called as the threshold value. With respect to the senior 0.6, that means you to go to the fuzzy set senior and make the threshold value 0.6, and you have to collect all the members from the universal collection who take the value either from 0.6 and so on. Let us go to senior level. This is senior 0.6 and above. We can include 0.6 also because equal to symbol is given here. 0.6, 1, 2. You look upon these values. You must not collect these values. Instead, you must collect their original domain. That is 65, 75 and 85 are the members from the universal collection. We possess the membership value greater than 0.6. Similarly for young and so on. This is one of the important analyzation in the pure mathematics background. When the alpha values are greater, when I impose conditions more, your sets will be shrink. When I impose threshold value or when I impose more and more conditions, your original set will be shrink. That means when alpha dash is greater than alpha, the collection, this alpha will be, this collection will be minimal collection as compared to the alpha dash collection. That is given here. Just a minute. Give a inference from the following diagram with respect to alpha cut. Here you can see alpha is 0, alpha 1.2, 1.4, 0.8 and 1.1. This 1 is given inside the concentric ring. Why it is given inside? Because the collection will be very minimal as compared to the other collection. There are another more concepts that is called as core and boundary. Comprises those elements X of the universe such that who are all taking the value as 1. See here in the diagram, this is the core portion and support is the non-zero membership. Non-zero membership is our support. This is the portion where we are having non-zero membership. Similarly, the boundary means 0 to 1 value. Or you should not include 0 and you should not include 1. That is the boundary value. And another more examples are scalar identity. It is given as sigma mu a of x, and relative scalar identity is relative means you have to see the normalization. Normalization is the relative scalar cardinality. Since we are having more informations, and this slide gives the difference between crisp and fuzzy sets, and also probability and fuzzy. Probability theory has nothing to reason about the things that are entirely true or false. It is going to address only degree of chances. Logic is all about degree of truth. Fuzzy logic captures the meaning of partial truth, whereas probability theory captures partial knowledge. These are some of the adverbs that related to probability theory: perhaps, possibly, and maybe. And adjectives for probability is given in this slide. And what is the growth of fuzzy set theory? Fuzzy set theory has evolved in the year 1965, and researchers group from Japan developed this theory in 1970s. In 1974, Mamdani from United Kingdom developed the first fuzzy logic controller, and control theory is placing a predominant giving predominant value to this fuzzy background. Du Bois applied fuzzy sets in a comprehensive study of traffic conditions, and in 1976-87, industrial applications of fuzzy logic in Japan and Europe, and 1987 onwards, it started its boom. And we are going to see very interesting information in this slide. Crisp set theory is used in digital systems because of the assignment of the membership value. Boolean membership value 0 and 1. Fuzzy set theory is used in intelligent system because of the assignment of membership values from 0 to 1. Intelligent systems are systems that can exhibit some sort of intelligence. For example, a simpler intelligent system would be the Gmail spam classifier that we can see in our mail. New computing methods based on fuzzy sets can be used in the development of intelligent systems for decision making, identification, pattern recognition, optimization, and control. Look here, this is the automatic braking system that can be addressed by the traditional logic. It is meaningless. It is not meaningful to be addressed this background of problem through crisp logic. Automatic braking system can be addressed by fuzzy logic with the words close and for. These are the linguistic values. These linguistic values is meaningful when it is addressed through crisp logic. How close it is, how far it is. To build intelligent system, Colab is a free Jupyter notebook environment that runs entirely in the cloud. Because we require memory, large memory, since we are not having that much of memory in our ordinary digital systems, we can adapt from cloud. Colab allows anybody to write or execute arbitrary Python code through the browser and is especially well suited to machine learning, data analysis, artificial intelligence, and education system. These are the domains which require intelligent systems. Colab Notebook execute code on Google Cloud servers. You can leverage the power of Google hardware, including GPUs and TPUs. Some of the applications of fuzzy logic can be viewed here. Washing machine, we are having washing machine. In that, fuzzy application is carried out, and microwave oven also fuzzy logic is applied. And to avoid collision on ship sailing in the sea or in the river, we use a fuzzy logic approach. Fuzzy applications are now in exponential growth, and a hybrid of fuzzy sets, some intra-related fields with this fuzzy set with respect to mathematics, fuzzy topology, automata, metric space, graph theory, algebra, optimization, and so on. Intra-related fields such as knowledge engineering, evidence theory, control theory, pattern recognition, image processing, and so on. Now, you have to answer in this situation. When corona be totally or partially eliminated from this world? Answer A is 85% chance of elimination, 0.85, that is 85% membership value for elimination. Which way of answering is correct? Why? The second way is correct because there is no chance of, there is no word representing chance. It cannot be addressed through probability theory, it can only be addressed through fuzzy theory. Suppose company A finds a medicine M1 to cure a disease and saying that 75% chance of curing that disease. Company B finds another medicine M2 and saying that curing membership value by the medicine M2 is 65%. Which company medicine you opt to buy? Obviously the second one. This is the chance for curing. This is a 65% guarantee for curing. This is the chance and this is the guarantee. So we will always adopt guarantee. Walking in the desert close to being dehydrated, you find 2 bottles of water. You are in the dehydration question. The first contains deadly poison with a probability of 0.1. The second has 0.9 membership value in the fuzzy set. That is safe trees. Which one will you choose? I will choose only the second one because 65% membership guarantee is there. Does the numeric value represented in the below diagram represent probability value or fuzzy membership value justified? Look to these words: impossible, unlikely, equally likely, likely, certain, and they are provided with the values between 0 and 1. Since these words addresses probability, this numeric value is taken from probability background. Are these sentences mentioned in the following diagram represent probability or possibility? The bus should be here in 10 minutes. Rice should be home this evening. These two information addresses futuristic chance, so probability theory comes into picture. Carefully go through the adjective adverbs given in the below table. Identify 5 adverbs and adjectives that can be used in the fuzzy linguistic variables. Because of the scarcity of time, we cannot work out these things. And look out these adjective words and also this diagram. Cold, warm, hot belongs to the linguistic variable or linguistic value. Surely these are the linguistic values to this linguistic variable temperature. Identify the suitable linguistic variables to cold, warm, hot from the above table. One of the linguistic variable is temperature. To the same linguistic value, we can opt another linguistic variable also. Cold, warm, hot. We can adopt weather. Okay, we can adopt weather in this context. Similarly, is there any other linguistic variable we can assign? You think and work out. Headings of the above small boxes represents linguistic variables or linguistic value. We are asked to identify headings given in these small boxes represents linguistic variable or linguistic values. These are linguistic variables. To these linguistic variables, the below are linguistic values. Frame suitable English sentence for the following diagram that address probability theory and fuzzy set theory. Today, tomorrow, day after tomorrow, rain and no rain. These are the chances. You can address this through fuzzy sets. Similarly, for this case also. And some of the Google books that are representing our topic of studies today. Computing with words in Information Intelligence System Foundation. This is published in Springer. Current approaches of computing with words only deals with semantics of adjectives or in other word qualities. Qualities are modeled by value assigned to linguistic variables represented by fuzzy sets. Example, Carol lives near Madurai. Carol is linguistic variable. Mary is another linguistic variable and near is linguistic value. Similarly, one more book that is Ville, Insight into Fuzzy Modeling, that addresses linguistic hedges. It is told that linguistic hedges has not been developed so far. And the tool, what is the tool that is available? Predominant tool is MATLAB. Through this predominant MATLAB tool, you can incorporate this technique, fuzzy techniques, to apply application problems. And fuzzy is also applied in the context of coloring. So my colorful thank you to you all for patience and listening. Thank you. Thanks a lot for this wonderful opportunity to meet you all virtually. Thank you so much. Victor? Victor? Victor?
Ma'am, thank you, ma'am. Shall the participants can ask any queries, ma'am?
Yes, you consolidate queries and you can if one of the organizers can address the question to me.
Okay, ma'am. All the participants, please type your queries in the chat box. We'll ask them, ma'am.
We have to thank the connection that is not disturbing us.
Participants, you can type your queries in the chat box. Ma'am?
Yes?
Ma'am, Dr. R. Suresh sir is asking, what are the membership function beyond triangular, trapezoidal, etc.?
Yeah. There are a lot more membership functions. These are the elementary membership functions that are available in the literature, triangular. While beginning this subject, assigning membership value is a separate ocean like Pacific Ocean and other oceans. Fuzzy membership functions like triangular, trapezoidal are available in the literature, and researchers on their own interest and referring with the existing mathematical theory, they have developed a hybrid way of membership function sigmoidal. That is a separate study. So that has to be taken in a separate session. Since classical set theory is an ocean, like fuzzy set theory is also an ocean, availability of membership function can be googled and learned. Any more, ma'am?
I'll wait, ma'am.
Okay.
Participants, do you have any queries? You can type on the chat box. Ma'am, not yet, ma'am. All are saying that it's very useful and fruitful session, ma'am.
Oh, I thank the organizer for giving me such a wonderful opportunity.
Ma'am, another one question, ma'am.
Complex
from Vignesh.
Complex number.
BV.
Okay.
How do we convert linguistic values into numerical values, ma'am? He's asking. How do we convert linguistic values into numerical values?
And for converting linguistic values into numeric values, we need a skillful expertise that can be provided by fuzzy numbers, and also that can be efficiently viewed by oneself in our own way. That is a another direction of study. That is another direction of study, assignment and numeric values. So only people are hesitating to take fuzzy into their hand. After knowing all these informations, we can have a special session on designing membership value, how to design. To some of the application, we have to assign only triangular membership. To another type of application, we have to compulsorily assign trapezoidal membership. To some another application, you have to assign sigmoidal membership. So there are so many membership available. Based on the expertise and the background of the problem, we have to select the membership function for assigning numeric value.
Thank you, ma'am. Next question is from Dhanashekhar Sundaram. Sir,
yes,
he's asking, are we going to use any software for clustering?
No. Since this FDP is from mathematical department, we are going to address clustering technique mathematically. After understanding this technique, well versed in the mathematical aspect, one can go and use the tool for clustering technique. If he is well versed and well knowledge in the mathematical aspects of this technique, then he can incorporate this technique in the tool in an efficient way. So we are going to address only in the mathematical part. What are the mathematics behind it? How to handle this session?
Thank you, ma'am.
Complex number, R. Suresh is asked the question
Yes,
that
ma'am.
complex number lies in the membership. No, because 0, 1 never allows it. The interval 0, 1 is purely real, is it not? So we cannot address complex numbers.
Thank you, ma'am.